Okay, and so if we look through all these things, our main idea is to somehow reduce the given network into the equivalent resistance form so that we are able to find out the current through various parts or the total current and all those things. Now, today, what we are going to deal with is some kind of analysis, like if you are given a whole network, how will you find out the current through each of these elements and all those things? So there are many methods. One method is mesh current analysis, other is node voltage analysis, and in later stages, in your higher semesters, you'll come across Thevenin theorem, Norton's theorem, etc., etc. So by the end of the 8th semester, you will be learning a number of theorems, laws, etc., over a period of which were developed over a period of centuries, number of centuries. We'll see, I have seen even my sons, etc., saying, oh, Newton ഇല്ലായിരുന്നെങ്കിൽ ഇതൊന്നും പഠിക്കണ്ടായിരുന്നു അല്ലെങ്കിൽ Einstein എന്തിന് ഇതുണ്ടാക്കി. So, but you should remember the whole luxuries, the whole comfort that man is enjoying now is because of all these people. So they are all like God for us. Not exactly God, but all divine for us. Because if not for them, if not for all these things, I wouldn't be speaking to you like this, and you wouldn't be learning anything. Now we will all be hunters, gatherers, like people, like culture. We'll be fighting with each other. We'll be eating some raw meat and all those things. So let's appreciate whatever our ancestors or whatever our scientists, old scientists have done. Okay, so all these are ultimately, particularly electricity, ultimately for the comfort of human beings, our lives. Okay, so today, let me present it. Today we are going to learn about how to solve a network, how to find the various currents in a network using mesh current analysis. I hope you have done this problem, which I discussed yesterday. Today we'll be dealing with mesh current analysis. Mesh current analysis. Now, I'm sure you have all done some sort of analysis like this, but yet again, I just want to go through this so that you will recollect whatever you have learned. I'm not going into the theory at all. We'll be doing a problem, and while doing the problem, we will be coming through the theory also. Okay, so I want all of you to draw this network. So this is the first problem that I am taking. For want of time, this is the only way in which I can proceed. So take down this network, all of you. The resistance, another resistance, and another resistance. Okay. Then I have another resistance and a source. Okay. $15 5 ohm, 10 ohm, plus minus 10 volt, 6 ohm, 4 ohm. Okay. Find the current through. Find the current through the 4 ohm resistor. Use mesh current analysis method. Mesh current analysis method. This is the question. Okay. So what are the steps involved? 1, assign mesh currents. assign mesh currents. So we do not know in which direction the current through the 5 ohm resistor is passing, in which direction the current through 4 ohm resistance is passing. Nothing we do, but we are arbitrarily taking mesh currents like this, I1 and I2. What do you mean by arbitrarily taking? I'm just assuming that there is a current I1 in mesh. This much is called as a mesh. This is my mesh 1 and this is my mesh 2. So I am considering two mesh currents, I1 and I2, in a direction that is arbitrary. Arbitrary means my freedom. Okay, I have usually the mesh currents are taken in the clockwise direction as shown. Okay, that is all. So I have considered two mesh. I hope you have also drawn these. So first step is to assign mesh currents. Second step is to apply KVL, apply Kirchhoff's voltage laws, KVL, to these meshes, okay, so that you get certain equations. So I will be applying KVL to the 5 ohm resistance voltage drop across the 5 ohm resistor, voltage drop across the 10 ohm resistor, 10 volt source and 15, that is mesh 1 and so on. Then third step, the resulting equation, you will get equations in small I1, I2. So you solve the resulting simultaneous equations. What do you mean by simultaneous equations? Equations which contain the value of, contain terms in I1 and I2. So because you have considered two meshes and because you are writing equations for each mesh, you will get two equations in the unknowns I1 and I2. So which is more than enough to solve for the values of I1 and I2. These are the steps involved. Now let's write the equations. Okay. Okay, let me delete this much. Okay. So shall we consider the mesh 1? I'm going to write the equation for mesh 1. Considering mesh 1 and I am applying KVL. Kirchhoff's voltage law. To which mesh? Mesh 1. Okay. So what about this 15 volt? Minus 15, because you are in this case current I1 is passing through the voltage source from minus to plus, or it's a voltage rise, plus 5I1 because there is a voltage drop of 5I1 in this direction, plus 10I1. 10I1, I can even write this as, what is the current through 10 ohm? What is the current through the 10 ohm resistance? It is I1 as well as I2. So because I am writing the equation for mesh 1, I'll write it as I1 minus I2. Because I am writing the equation for mesh 1, I1 comes first, I1 minus I2. And what about this voltage source? It is a voltage drop, so plus 10. Okay, plus 10 equal to 0. So I can rearrange the terms and reduce this equation into 3I1 minus 2I2 is equal to 1. That is equation number 1. Okay, now I am considering mesh 2. Let me consider mesh 2 and apply KVL in the same manner. Which is mesh 2? Mesh 2 is this. Okay. So in mesh 2, when I write, okay, 6, I am considering this resistance, 6I2 plus 4I2 plus 10 into, now when I write the current through the 10 ohm resistor, I will be writing 10 into I2 minus I1 plus, again I have a source 10 volt here, Here the current I2 is flowing from a negative polarity to positive polarity in this direction, which means it is a voltage rise. So it is actually minus 10. It is actually minus 10 equal to 0, which on reducing you will get as minus I1 plus 2I2 is equal to 1, equation number 2. So I have arbitrarily taken I1 and I2 in a direction which I like. Usually, conventionally, you always take it in the clockwise direction. Whichever direction you take, it's okay. But then I write the equation for mesh current 1 and mesh 1 and mesh 2. You apply KVL and I get two equations here. The equations are equation number 1 and equation number 2. On inspecting equation number 1 and equation number 2, I now understand that there are two unknowns, I1 and I2, and I have two equations, which by substitution method I can directly get, or I can even use a matrix formulation. How do I write the matrix formulation? How do I write the matrix formulation? All of you should listen now. Okay, that is, I have to write a matrix equation like this, where I put I1 and I2 are as the unknowns. That is equal to this. So what I want to write is I have to fill up these values. Now, if I look here, it is 3, 2I2, minus 2. Here, minus 1. Here, 2. What is that on the right hand side? 1. What is there on the right hand side? 1. Or what I have written is 3I1 plus minus 2I2 is equal to 1, which is my first equation. Similarly, minus 1I1 plus 2I2 is equal to 1. This is my second equation. Okay. Now, having got this in a matrix form, why I am writing in a matrix form? Because if the matrix was, if I get a very complicated 3 by 3 or 4 by 4 matrix, it is much easier to use. Instead of using substitution method, it's much more easier to use what is known as, I hope you have come, someone should answer. Rishikesh, have you learned Cramer's rule, Rishikesh? Have you ever learned Cramer's rule? Rishikesh?
Yes, ma'am. Not in school, but
okay. Okay, not in school anyway, no? Okay. So you can use Cramer's rule. How do you use Cramer's rule? You can solve for I1 and I2 by using Cramer's rule. All of you just listen how I'm going to use it. Okay, delta is equal to whatever matrix that you have here, that converted into delta, that converted into determinant. You are going to find the determinant 3 minus 2 minus 1 2. This delta value, whatever matrix that you had, the determinant value of that matrix is delta. That you will get 3 into 2, 6 minus 2 will be 4. Okay. Now, if I want to find out I1, what I will do is some other determinant divided by that delta. Which determinant? Again, this determinant. If I want to find out I1, I'll replace this first column element by this value, which means I'll be writing 1, 1, minus 2, 2. This column remains the same, divided by 4, which means this will be equal to 4 divided by 4. This 4 is the determinant value. That is I1 is equal to 1 ampere. Similarly, if I want to find out I2, it is again another determinant by delta. Delta is equal to 4, which I have already found out. I2, in order to find out I2, I replace the second column by 1, 1. Okay. So first column remains this. That is, I'll have 3 minus 1. Second column becomes 1 and 1 divided by delta. This again happens to be 4 by 4 is equal to 1 ampere. Okay, this is how you use Cramer's rule. And you know you have been asked to find out the value of current through the 4 ohm resistor, which is I2, which means I just have to find out I2, which is 1 ampere. Okay. Hope this is clear. Hope this is clear. Now, what I want to tell you is, instead of going through the whole process of writing the equations, etc., now I have understood that even by just an inspection of all these, I can write the matrix equation and find out. Let's see how. Okay. This is our circuit. Now, even without going for the equations, the same equations can be directly written through matrix equation. How? Let's see. All of you should listen. This is very important. I'm going to write the matrix equation directly from the network. Okay. I1, I2. So all of you know that this position is A11, this position is A12, this position is A22, this position, sorry, A21, this position is A22. That is how you write the matrix equation. First, A11 means first element in the first row and first column. A12 means second element in the first row. So row comes as the first decimal. Okay. So how will you write now? By looking into in the network, just look into the network and think about all the resistors that are connected in the first mesh, including the common elements, including the common resistors. The resistors will be 5 plus 10, 15. Okay, 15. A12 is those resistors, the sum of those resistors which are common to I1 as well as I2, which are common to both meshes, which is that you only have one resistor here, that is 10. So I write 10 here with a negative sign because I have through 10, I1 is going in this direction and I2 I have taken in this direction. So I am writing it as minus 10. Okay, minus 10. Then A21 and A12 will be the same, isn't it? A21 and A12 will be the same. Again, this will be minus 10. And what about A22? A22 means all those resistors which are connected to the mesh 2, including the common elements. So 6 plus 4 plus 10, or it will be 20. Okay. And what about here? The voltage source which is there in the first mesh. One voltage source is 15 volt. Another mesh voltage source is 10. In which case 15 is giving current. So it's a positive current. But I1 has been chosen in this direction, which is opposing the source current, which may be produced by the 10 volts. So it will be 15 minus 10, 5. And here 15 minus 10 is 5. And what about here? I2. In the second mesh, I2 is in the same direction as the voltage source. So I can write it as 10. I want all of you to listen. I want all of you to just, I'll give you 1 second for you to just digest whatever I have written. If you have any doubts, I want you to ask me. This is very important. If you have understood this mesh current analysis is not a problem at all, even in your future. Okay, I hope all of you have understood. Now, this is the same thing that we have written as the previous matrix also. If you find out the value of using Cramer's rule, if you use Cramer's rule and find out I1, you will get 1 ampere. If you use Cramer's rule and find out I2, you will again get 1 ampere. This is the same as what we had done, because this matrix is actually written on the basis of those equations, on the basis of the equations written using KVL. Okay, so this is mesh current analysis. So I hope you have understood. Now I'm going on to a little more, not a complicated, little more complex network. Okay, so let's see how you can solve this. Just draw this circuit diagram. I don't know how far you have understanding. It's like talking to a wall. I'm just talk, or as though I'm talking to myself. I don't know how far you have understood. I mean, it would be better if you can give me some feedback also. If anyone feels that, sorry, this is 24. If anyone feels that I'm going fast, I'm going slow, or is it, if you are feeling that it's very boring, please feel free to tell me, because these are all, simple things, yet some of you may find it difficult to even recollect. So I want all of you to listen. I want all of you to take part in whatever is being done. Now, what I am going to do now, all of you should listen. This is not the single network that I'm going to deal with. I may in future try to introduce an independent source here. Okay. Sorry, dependent source here. So what my idea is, first we'll see how I'll be writing the matrix equation for this network. Okay, so let me see, we'll take I1 arbitrarily, I2, I3. All I have taken in the clockwise direction. And try to write the matrix equation. So matrix equation, as you know, because there are three currents, mesh currents, the matrix equation, the A matrix or the matrix will be a 3 by 3 matrix. So all of you should listen. I'll give you time to write. Just listen, and then we'll all write this together. And then, no, you all listen to me while I write this, and then I'll give you 1 minute for you to write. All of you should check whether whatever comes to your mind is that which I am writing, or else tell me. Okay. So A11, which means all those elements which are connected to the first mesh. Which are they? Including the common ones. Okay, which are they? I'm just considering this mesh alone, first mesh alone. Which are those elements or those resistors which are connected to that only 10 plus 12, 22. Then I am going to find out A11, A12. 12 means those elements which are connected to both mesh 1 and mesh 2. That here you have only 10 with the negative sign, because I1 and I2 are in the opposite direction while passing through 10 ohm. Then 1, 2, then 1, 3. 1 and 3. The only element is 12. Again, I'll put a negative sign. This is I1, I2, I3. I hope this much is clear. Now I'll be considering the second row. Second row means, sorry, I3. Second row is concerning the second mesh. So A21. A21 is the same as A12, that is minus 10. A22 means all those elements which are connected to mesh 2. Mesh 2 is this, as you know. So that is 10 plus 4 plus 24. 28 plus 10, 38. 2, 3. 2, 3 will be 4 with the negative sign. Minus 4. 3, 1. 3 and 1, minus 12. 3 and 2. 3 and 2 is minus 4. 3 and 3 is 3, 3. 8, 3, 3 will be 12 plus 4, 16. Okay. Then the coming to the voltage sources. In the first mesh, there is 24 volt driving the current in the same direction. So 24. Second mesh doesn't have any voltage source. Third mesh doesn't have any voltage source. I want all of you to solve for this. How do you solve for this? Cramer's rule. So find delta, which is the determinant of this. I1 will be the first column replaced by 24, 0, 0, minus 10, 38, 4, minus 4, minus 12, minus 4, 16, divided by this value of delta. I2 will be, first column remains the same, 22 minus 10 minus 12. Second column replaced by 24, 0, 0. Third will be minus 12, minus 4, 16, divided by the same delta. And in the case of I3, you will be replacing the third column with that of the voltage source values, that is 24, 0, 0. Now the Cramer's rule becomes very easy because each time you are replacing with 24, 0, 0. So in this case, when you calculate the delta, you consider this column for finding out the value. In the second case, you consider this column for finding out the value of the determinant and so on. Okay. Now, having said all these things, now I am going to change my question a little bit. How? The class is over. As per this, my alarm has come out. But I'm going to make a small variation. I'm going to ask you what to do. Okay. So, suppose I'm going to change my question a little bit. Okay. How to change? I'm going to add a dependent source here. Okay. I'm going to put a dependent source here. In the third loop, third mesh, I'm going to add a dependent loop. This is plus minus 4 I naught, where this is I naught. So what change will come in the mesh equation? Now you have to, this is you can write it as homework. Write this. How? Write the mesh equations instead of the matrix equation. Just write the matrix equations so as to get the feel of it. Okay. Only for the third mesh there will be a difference. For I naught, what is I naught? I naught is this I1 minus I naught is I1 minus I2. I naught is I1 minus I2. Or sorry, I have to write it in this manner. I naught is I1 minus I2, isn't it? The current through the 10 ohm. Okay, 4 I naught means 4 into I1 minus I2, which means the last column of the matrix equation will get changed to something like this. Check, and if you have any doubts, tomorrow we'll discuss that also. For now, I'll write that matrix equation and check whether you are getting that. Okay. This remains as 24, 0, 0. This is I1, I2, I3. Because I1 and I2 comes, the third row changes. That is, this first column is the same. First row is the same. 22 minus 10 minus 12. Second row is minus 10, 38 as before. Same, minus 4. The last row becomes 8 minus 8. Minus 8, 16. Check whether this change is coming. Check whether you have understanding this change. If not, we'll discuss tomorrow. There will be a change in this because when you consider this as a resistance through which both I1 and I1 and I2 are passing, also I3 is there, which means that makes a lot of change in the third row. It's not a simple thing just to inspect and write. I hope you have understood this. check whether you have understood how I wrote the last row. If not, we'll be discussing next in the next class. Okay. So that's all for today, because 30 minutes is hardly sufficient to finish any portion to my satisfaction. As I told you, it's like talking to computer, which if someone in the past have seen, someone like my grandfather or grandmother has seen me now, they will really think that I have gone mad. You know, who is she talking to? She's talking to a machine. So we are like gods, people to ancient people. Suppose someone in the ancient era, or someone in the islands near Lakshadweep, where you have a tribal people. If those tribal people sees me or sees us now, you're talking to a doing WhatsApp or talking to a hands-free machine, etc., or even to an online class, they'll think that we are all gods with divinity. Okay, thank you. That's all for today. Check whether you're getting the elements in the last row. Okay. If not, we'll discuss tomorrow.